Hello, this is John from caveofprogramming.com. In this tutorial we're going to start working on creating a simulated explosion effect. So at the moment our particles are all starting in random positions and they're wandering around the screen randomly. Well, actually they all have fixed speeds and directions, and they bounce off the edges of the screen and just kind of wander around. So what I'd like to create here is an explosion effect where they all start from the middle and they all fire outwards in a sort of circle, a sort of jagged circle. So let's start putting that together in this tutorial. And what we want to get to start with is that circular kind of explosion pattern of the particles. So if we look at particle.cpp now, we've got it that we're initializing the x and y coordinates of each particle to a random value when the particle's created. Let's get rid of that and instead put the particles using the constructor initialization list here. Let's put them right in the center of the screen, which in our particle coordinate system is at 0, 0, x equals 0, y equals 0. And if we run this now, they start from the center of the screen, but you'll notice there's a rectangular pattern to the explosion. That's because we're choosing the x and y values here randomly, but using a rectangular coordinate system like that and choosing the x and y speeds of the particles separately is what leads to this rectangular pattern. What we really want to do is we want to choose two things for each particle. Firstly, a completely random direction from 0 to 360 degrees, and secondly, a speed, so that we're not introducing any kind of rectangular elements in there. And if you've done any mathematics, you'll recognize this as basically changing from Cartesian coordinates, which we're using at the moment, to polar coordinates. But if you haven't done any mathematics, don't worry about that. Because the formulas that I'm going to show you, you don't really have to understand them unless you're going to do a lot of detailed graphics work. You can just use them. So instead of having an x speed and y speed for our particle, I'm going to go to particle.h here, get rid of those, and instead of those I'm going to have a double m underscore speed, which will just be how fast the particle is moving in whatever direction it's moving in, and a double m underscore direction, which will be the angle from 0 to 360 degrees that the particle moves in. And then in particle.cpp, let's get rid of the update method because that's now not in use anymore. And let's get rid of this stuff that initializes the x speed and y speed because we're not using that anymore. Let's start by picking a random direction for the particle. So again, we'll use our old friends rand and randmax here. We divide, rand returns a random number from 0 up to whatever randmax is, which is a big number. So if we do this, we'll get a number from 0 to 1.0, except that we have to make sure that either randmax or rand is converted to a double first, or else we'll get integer division, which will just give us 0, discarding the floating point bit. And in fact, in mathematics in general and in programming as well, angles are not measured using degrees but using radians, or some people say radians. And the radian measures a full rotation, not in 360 degrees but in 2 times pi radians. Like pi is 3.141592 roughly. 2 times pi is going to be something like, I suppose, 6.3 roughly. So we measure the full circle of rotation from as being not from 0 to 360 but from 0 to 6.3 roughly, and that has various mathematical advantages. So we want to pick an angle here from 0 to 2 times pi, which is about 6.3 I think, radians. And we can use a constant, a pi constant from math.h. So let's use that. Let's say here 2 times, and the constant's called m underscore pi, and it's about 3.141592 times rand here. You might need to You might need to include using namespace standard here, but it seems like I don't need it, so I won't put it in. Seems to be fine that we don't need to use a standard namespace to get this m_pi, at least on this system anyway. Let's put this in brackets to make sure that we have a double here. We're dividing, the numerator is definitely a double before we divide by the integer denominator, because we have to have either the top bit, numerator, or the bottom bit of the fraction, denominator, as a double in order to make C++ do floating point division. This is choosing our angle, and then we're going to choose the speed. So m_speed, and again, rand divided by rand_max will give us a random number from 0 to 1.0, and we can multiply that by some constant. Let's try some number. So I'm just going to experiment with some number here, and again, it's floating point number, of course. It's very important. I tried different values. I just experimented with different values and found some that work for what I'm going to do here. So you can experiment too and see what results you get. So we've got the direction and speed, and in update now I can calculate how much to move the x and y coordinates by. Let's have a double let's call it, have a double x speed equals, and the formula here, which you'll recognize if you've done any mathematics, but if you haven't, don't worry, is if you've got a direction and a speed like this and you want to calculate a x speed and a y speed, the x speed is the speed times the cosine of the direction, and we're using cos and sine from math.h, and the y speed here is going to be m_speed times the sine of the m_direction. These are just functions that basically give us the right values projecting onto the x and y coordinates. So now we can add those on to m_x plus equals x speed and m_y plus equals y speed. Let's run this and see how it looks. So this is very, very slow. Let's quit it and let's make this constant smaller for the speed, so a bigger speed. Now it's quite fast actually. I want to slow it down a bit. We'll try that, and we'll also maybe have more particles. Let's go to swarm.h, and let's try 5,000 particles, which this computer at least can cope with. And if yours can't, you might want to stick with a lower number of particles, but this looks good on this computer at least. Go back to particle.cpp and let's run this. Now we've got an explosion, but it's beginning to look like an explosion, but you'll notice it's oval and not circular. So let's at least fix that in this tutorial. Now that the speed, by the way, at the moment it's going to depend on the speed of your system. The speed that these particles move at is just going to depend on how quickly this loop can iterate in main.cpp, and that's not desirable either. We'd like it to run at the same kind of speed on any system, so we need to fix that as well. But the last thing I'm going to fix in this tutorial is just to stop it looking oval. The reason it looks oval is because of we're taking the particle space and mapping it to screen space here in main.cpp, but the screen is wider than it is high, and because we're trying to fit that -1 to +1 on x and y kind of box neatly into the screen, and because the screen's wider than it is high, we end up with an oval. We've mapped the particle space in such a way that gives us this oval. The key to not having an oval there is to make sure that whatever the coordinate of the particle is, we always multiply it by the same value both for x and y. So the range of the particle, which is 2, that's from -1 to +1, is a range of 2. We then multiply it by half of the screen width, for example, to get a range of the screen width. But that gives us a different range for the width and height, because we're using the height to multiply the range of particle range of 2 from -1 to +1 to map that to the height. So let's change these so that instead of using screen height here, we're using screen width. Now this is a step in the right direction. So this means that the x and y range of the particle is going to be the same, but the explosion now starts from, it's not the centre of the screen anymore, but you can see that it is circular because the range of it is the same in both the x and y directions. To fix that, we're going to have to rethink the height calculation a bit. What we'll do is first we'll take the, let's get rid of some of this. First we'll take the y coordinate and multiply it by this, the screen width divided by 2, because that will extend the range of the particle. It will change it from 2, -1 to +1, that's a range of 2, to the screen width, which is fine. Particles are going to go off the edge of the screen, off the top and the bottom, but it doesn't matter because the width is bigger than the height. But if they go off the top or the bottom, it doesn't matter, because we've made sure on our set pixel that we aren't going to plot any particles that are off the edge of the screen, so we can safely do this. We don't have to worry about exactly where they are. Now we need to, once we've got the range right here, this at the moment, if the particle is at position 0, that will mean that it will be at 0 on the screen, which will be right at the top of the screen, because y starts numbering downwards, so the 0 of y is at the top of the screen. If we run this now, we get this, it's right at the top here. What we want to do is add to that half of the height. So if we add to this screen screen height, let's use the autocomplete there, divide by 2. Now if we run this, we get it in the right position, because if you think about it, when the particle's at 0, 0 times screen width over 2 is still 0. Add half of the screen height, and that puts the 0 right halfway down the screen, which is what we want. So I think I'm going to leave it there for this tutorial. This is a little bit inefficient because we're doing this division by 2 every time we go around this loop. And if you want, you could define a constant above the loop equal to the screen width over 2 and use that here to avoid having this calculation, the division by 2, to avoid doing it every time you go around a loop, which might be a good idea. The compiler might optimize that anyway, but best not to rely on it. But I'm just going to leave it as it is for the moment. So we'll continue to work on this explosion in the next tutorial. We've got a few things to fix here because it's still not what we want it to be. It also looks very rubbish because, well, we're changing the colors of all the particles at the same time, and we haven't, more importantly as well, we haven't got a blur on the screen. We're just seeing individual pixels, and it looks a lot cooler if you blur the screen. So we've still got to tackle that, but I'll leave it there for this time, and until next time, happy coding.